Hello Algebra 2. This is the part 2 of the day 4 notes, and our learning targets are the same from the beginning of our day 4 notes. So we're going to be able to recognize the standard form of a quadratic function, and you will be able to solve a quadratic equation by graphing. And third, you'll be able to describe the relationships among the solutions of an equation, zeros of a function, x-intercepts, and factors of a polynomial expression. And this was in the last video, but just remember, whenever I say the word standard form of a quadratic function, it's in this form: ax squared plus bx plus c, where a, b, and c are real numbers, and our a is the number in front of the quadratic, the x squared term, and our b is the number in front of the linear term, our x, and our c is our constant. Remember that the graph of a quadratic function is called a parabola, and we can always graph any function with a table of values. So we will find numbers. If we forget all the ways to graph it, we can always go back to our table of values to find what a function looks like, or any equation looks like. And then in the last video, there are some rules to help you so that you don't have to create the table if you do not want to. And the first rule was that the y-intercept would be a constant, would be your constant term. So because if you just think about the definition of a y-intercept, the x value would be 0. So you would substitute in a 0 for both of these x's, and that's why your y-intercept would be c, because the value of x is 0, and so whatever your c is in your quadratic equation would be your y-intercept. Also, the equation of an axis of symmetry, you can find that by setting your negative b over 2a. So you can take your equation and have the opposite sign of b and divide by 2 times a to find the axis of symmetry. And because that value, that axis of symmetry, goes through your vertex, that's also going to be your x-coordinate. And then to find the y value, so to find the whole vertex, the x and y value of your vertex, the x can be found that way, and then the y value of the vertex can be found by taking that x value and substituting it into the equation. Lastly, our graph will go up when our a value is greater than 0, and it will go down when it's less than 0. Okay, let's now try this in this problem that's on your notes. So we have our equation. We're going to find our y-intercept by looking at our c value. And again, if you forget this, remember our y-intercept is where it crosses the y-axis. So our x value would be 0. So if you forget this rule, you just know that always your y-intercept, the x value is 0, and you can substitute 0 in for both. So in this case, our y-intercept is 4. And we can graph that. We know already our y-intercept is at 4. Okay, to find our equation of the axis of symmetry, we can use that formula of x equals negative b over 2a, and our b value in this case is negative 4. So I substitute in negative 4 for b, and then our a value and this equation is 1. So let's just write that out so you can see that. So our a is always the number in front of x squared term. Our b is our number in front of x, and then c is our constant. Okay, so our b again is substituting -4 in for b, and then our a is 1. So to find our axis of symmetry, we simplify this equation. So negative times a -4, -1 times -4 would be 4, and then 2 times 1 is 2. So our axis of symmetry is x equals 2. So we can graph that. Our axis of symmetry, we know that our vertex is somewhere on this line. Our x value of our vertex is 2, and we can take that and substitute into our equation to find our y value. So our f of 2, find our y value for our vertex, would be, our equation here is x squared, so I'm going to have 2 squared, and then -4 times 2, then +4. So we simplify and we get 2 squared is 4, and then a -4 times 2 would be -8, and then +4. And we end up with 0, because 4 minus 8 is -4, +4 would be 0. So our vertex is 2, 0. So already we can see our graph. Okay. So we can start by using these points to create a table of values. We already know one value from our y-intercept, and we know our vertex. We can find other values by just using our knowledge of the axis of symmetry. So because this point we found has to be symmetric on the other side, we can reflect that point over our axis of symmetry. So we know that there has to be a point at 4, 2, because our parabolas are symmetric. So our graph we have on our coordinate plane, we have enough points to go ahead and draw it so we can stop. If our parabola was down here and we needed some more points to get our graph making sure it's the right shape, then we could substitute in more x values to get a better picture. But right now, this one is, we can see the shape and our parabola, we're all set on the graph. So we only needed one more point in this case, and that would be at 4, 4, using our knowledge of the symmetry of a parabola. Okay, our last port. Okay, so I just realized I said that wrong originally the first time. This point should be 4, 4. When I was plotting it over here, I said 4, 2, but it should be 4, 4. So I wanted to make sure you wrote down on your table 4, 4. Okay, the last part I touched on in the first video has to do when our graph, when the y values are zeros. So when our function is at 0, you notice you have an x-intercept, and that is going to be our solutions. So anytime they ask for the word solution, you're looking for the x-intercept. So when they ask to solve the quadratic equation, you can solve it by graphing by setting equal to 0. And we already graphed it, and so we can see where the function is 0. So in our graph, and the one before, we can see the function is at 0 when our x is 2. So when they asked us, we can solve by graphing, and look for the x-intercepts. And in this equation, we know the x-intercept's at 2. That's when the y value is 0. So that's what they mean by solving. Anytime they ask us to do that, sometimes they won't set equal to 0 just be written like this one was, where it was the function equal to that. So you have to realize if you're solving by graphing, then you're looking for the x-intercept. Where is the y of 0? In our last video, we are going to solve algebraically. So you can solve them by setting equal 0 and solve algebraically, and we'll be talking about that in the next video. This one is about solving by graphing. So we'll be looking for our x-intercepts when we solve by graphing, because that's when the y is 0. So that's why another word they call the solutions are zeros. They're talking about when the y is 0. So the question could be asked using these terms: solve the quadratic equation. It could say find the zeros. It can say find the x-intercepts. But also it could say find the roots. And we'll be distinguishing between the real roots and other types of roots in our last video. So when you solve by graphing, you're looking for the x-intercepts. And there's 3 ways that you can have how many solutions. The first time you can have 2 solutions, like we talked about in our first video, where it crosses the x-axis twice. So those are 2 real solutions. Then you could have 1 real solution, like we did in our graph, our example, where the vertex was right here on the x-axis, so there would only be 1 real solution. You could also have the x-axis have a vertex on it and the parabola go down, so that still would be 1 real solution. And lastly, we would have no real solutions when it did not cross the x-axis. So some examples are shown visually here, and your vertex would have to be above the x-axis and the parabola going up for it to have no real solution, or the vertex be below the x-axis and it going down. So there are possibility of having 2 real solutions, 1 real solution, or no real solutions. And the next question I want you to ask yourself is, why can't a quadratic equation have 3 or 4 or more solutions? Go ahead and pause the video and try to answer that question on your own, and then bring it back. Okay, so you should have determined that the quadratic equation is impossible to have 3 or 4 or more solutions because of the shape. So because of our shape, it only has 1 turning point, and it's either going up or down, so that's why it can't have any more. The only possibility, the most it could cross, would be twice the x-axis. Okay, now I want you to try A and B. By graphing, I want you to graph A and look for the solutions, and then I want you to try B and look for the solutions. Now remember, with B, you have to set equal to 0 before you graph, so you have to subtract 3 from both sides and then go ahead and solve by graphing. Try both A and B and bring it back. Okay, for A, you should have found your y-intercept is -6. You knew your A is -1, so the graph is going down. When you substitute into the axis of symmetry equation, you should get the axis of symmetry equals 2. So your graph has that axis of symmetry. Then you know your vertex is somewhere along this point, so you take that value of 2 for x, substitute into your equation to find your y value. And that would be at -2. So your vertex is at 2, -2. Then you plot your points, use your knowledge of symmetry to find a third point, and graph your parabola. Since your parabola is going down and the vertex is below, you have no real solutions for A. When it came to B, when you did your graphing again, you found that there were real solutions. those are the x-intercepts at -1 and 3.